1.4 complex numbers. Fill in the blanks. The imaginary unit I is defined as the square root of -1. So that's not a real number. For instance, the reason we know that is because if I say, what's the square root of -1? Well, let's kind of move on more to the definitions. For instance, if I say the square root of 4 is 2, that's because 2 squared is equal to 4, right? So if I say the square root of -1 is equal to, I don't know, because we don't actually have a real number that you could square that would give you a -1. So for instance, if I square a -1, I get a +1. If I square a +1, I still get a +1. So this right here is the situation we're dealing with. What do we do when we're taking the square root of -1? Well, we can kind of put a little placeholder there of the I. So whenever we see a square root of -1, instead we can put an I there as a placeholder, and sometimes we can work around it. And we'll do a few examples of that. So I squared. So I squared is really saying this, oops, which is that. Hopefully that kind of makes sense. So if I square the square root of -1, I end up with a -1. So the set of numbers in the form of a plus bi is called the set of complex numbers. So if I can have in a space, complex numbers. And this is basically saying we have the real component and the imaginary component, which makes it a complex number. So if they're saying b is not equal to 0, that means you actually still have this component right there, that imaginary component right there. And we call this imaginary. Okay. And if the b is 0, the coefficient, that means there's not an imaginary component. And if there's not an imaginary component, then you end up with a real number. Oh, it's redundant putting complex numbers next to number. My bad. Okay, so we're going to determine the conjugate of 9 minus 7i. And the conjugate is basically the same binomial, but with opposite signs. So 9 minus 7i turns into 9 plus 7i. Okay, so we're going to complete the following sentence. The divisor 3 plus 6i divided by 2 minus 2i is performed by multiplying the numerator and the denominator by the conjugate of the denominator. So, by the conjugate. Conjugate. Okay, so write an expression in the standard form of a plus bi. Let's try that. So, what you do is you combine like terms. You basically treat the I at this point as a variable. So you're saying -8i plus 6i, and that would give me a -2i. Now, the order is not an accident that says a plus bi. So basically you have the real part goes first, and then the imaginary component, if you have it, goes second. Imaginary? I can't spell, sorry. We'll just pretend like that actually says imaginary. All right, so let's say 8 plus 8 is 16, right? So like terms. We're combining like terms, basically. So let's try the next one. Now the next one says 5 plus 6i minus 9 minus 7i. So just like before, we distribute the negative. You can treat it as a -1 or just flip all the signs. So -1 times +9 is -9. Minus 7i turns into plus 7i. And we still keep the 5 plus 6i. Now we combine like terms. Let's see, it's a 5 minus 9 is -4. And then we say 6i plus 7i. And that's going to give me a plus 13i. And that's it. So find the following product and write the result in the standard form of a plus bi. So now we distribute it, and again, we just treat this basically as a variable, the I. Except this one has an extra step at the end. So 6 times 3 is an 18. We keep the I. We say 6i times -i would be -6i squared. And here's where that definition comes in, where I was equal to square root of -1, which means if you square both I squared, you're really saying, right, that square root of -1 is being squared, which just gives you a -1. So what we're going to do is we are going to substitute in a -1 for the I squared. And then we're going to say 18I, -6 times -1 is +1, or sorry, +6. And because we want to put it in this form a plus bi, we have to put the real part first. So that would be a 6. And then we're going to put the imaginary part second, which is the 18i. All right, so let's try this one. This one's going to be a little bit different in that we have a binomial times a binomial. So we're going to say -2 times +8 is -16. -2 times +I is -2i. You're going to say 4i times 8 is going to be positive. 4 times 8 is 32, and we keep the I. And then we say 4i times I is going to be 4i squared. We're going to combine like terms a little bit. You can either combine like terms now, or you can wait until after you do your substitution. Might as well wait until after we do the substitution, I guess. So what that would mean is, where I have the I squared, I'm going to put in a -1, which means instead of this being a positive 4i squared, now it's going to turn into a -4. Now, once you kind of notice whenever you plug in a -1, that's just simply going to flip the coefficient sign. You can use that. That's going to happen pretty often. So -2i plus 32i. Okay, now we combine like terms. So we have a -16 minus 4, and that would give me a -20. And then we have a -2i plus 32i, which gives me a positive 30i. Try a few more problems. So now we say 8 times 4 is 32. 8 times -3i is -24i. -6i times 4 is -24i. We say -6i times a -3i. And we would say -3 times -6 is a positive 18. And we say I times I is I squared. And just like I said before, when you substitute this in, the I squared turns into a -1. -1 times positive 18 turns into a -18. So again, you can actually skip right in that step if you want to. It's always pretty much going to be the case. Okay, so we combine like terms. We have a 32 minus 18, and 32 minus 18 should give you a 14. And then we would say -24i minus 24i is -48, or minus 48i. There you go. So let's try this one. You can use pattern on this, but I haven't taught it yet, so we'll do it the long way. So 7 plus 8i multiplied by 7 plus 8i. So you'd say 7 times 7 is 49. You would say 7 times 8 is 56i. Then you'd say 8i times 7, which is plus 56i. Then you'd say 8 times 8, which is plus 64i squared. I times I is I squared. Okay, now we flip it. So we're going to keep the 49 plus, and 56 plus 56 is 112i. And then you would say, instead of it being a plus 64i squared, you would say it's minus 64. Combine like terms. The 49 minus 64, which would be a -15. And then you would keep the plus 112i. Next, you're going to say divide the expression and divide and express the results in standard form. That's fine. So what we would basically do here is we're going to multiply by the conjugate. Okay, so the conjugate of 5 minus I is 5 plus I, and then we also multiply the numerator by 5 plus I. So on the bottom, what's basically going to happen is we already did this pattern before, is we're going to have 5 squared minus I squared, right? First term squared minus the second term squared. So what we're going to have is a 25 plus 1, and then 25 plus 1 is 26. So you can kind of leave this in a factored form pretty often, or you can distribute it, the numerator. They're both pretty good options. So I'll distribute this one. 7 times 5 is 35. 7 times I is going to be plus 7i. And we're going to put that over a 26. Doesn't look like that's going to simplify any further, so we are done. And the way you know that is because when I had it all factored out in the previous step over here, there's nothing that I can divide into a 7 and a 26, but a 1. The GCF is 1, so you're done at that point. So by looking at it in the factored form, we know that it will not simplify further.